Hello and welcome to Matrix Live. It's been a long time since we last talked about P2P Matrix because, as you know, the Matrix Foundation is financially conservative to be sustainable. P2P Matrix exists as a prototype today. The idea is great, but it still has significant issues that prevent it from being usable in the wild. Today I am with Ben and Florian, who worked on ReP2P Matrix to fix some of these flaws. Florian, Ben, I'm going to let you introduce yourselves and show us your work.
Yep. Hi, I'm Ben from the Karlsruhe Institute of Technology, and I'll be presenting our work on ReP2P Matrix, which is also joint work with Florian.
Yeah, Florian also from Karlsruhe, who has supervised Ben in this work.
Yeah, that's right. So I'm going to be talking about ReP2P Matrix today, which stands for Relay Enhanced P2P Matrix. We published a workshop paper about this at the CONEXT Workshop for Decentralization of the Internet. And the subtitle of the paper is Decentralized Relays to Improve Reliability and Performance of P2P Matrix. So let's start with a little motivation. So on the one hand side, we have federated matrix. Most of you probably know the home servers like Synapse, Dendrite, or Conduit. A major challenge or flaw of federated matrix is that we cannot switch between home servers. So we might want some flexibility in the matrix world when a home server goes down, that we can still continue sending our messages. On the other side, we have P2P Matrix. We've seen several different implementations based on Pinecone, P2P over LibP2P, and Yggdrasil. And one major problem is that P2P Matrix does not allow asynchronous delivery. So peers have to be online at the same time in order to send or receive events. Our work is called ReP2P Matrix, where peers can switch between relays, which improves the reliability. And also it provides asynchronous delivery, which means improved performance. So what does asynchronous delivery actually mean? In our approach, we deploy constantly online relays that store and forward events. So here we have a little example of a room consisting of Alice and Bob and one relay as the room members. This black line stands for Alice being online. So at the beginning, Alice is online while Bob is offline. At this first stage, obviously, Alice cannot send any events. That's why Alice first sends the event to the relay and returns offline. Bob then comes online and resyncs with the relay and receives the previously sent event. And this is a major difference to P2P Matrix, because in P2P Matrix, Bob would have to wait until this last online period until he would receive the event. And so in total, ReP2P enables asynchronous and as soon as possible delivery. And one of the main differences to home servers is that peers can switch between relays. And I say relays here because there can be multiple relays in one room. So let's scale out a bit and look at how events are disseminated in ReP2P Matrix. Now let's assume we have a set of online peers consisting of Alice and two other online peers, and some offline peers such as Bob, and also a set of room relays. Now let's assume Alice wants to send an event into a room. So she first sends the event to all the other online peers via a P2P Matrix mechanism such as Pinecone. And in addition, she sends this event to one of the room relays, which in turn forwards this event to all other room relays. Now, after a while, Alice and the previously online peers return offline, and Bob returns online. And obviously, he would want to receive all of the events that had been previously exchanged. So Bob decides to resync with a different room relay and receives all the events that have been exchanged in the meantime. Now, how are these relays actually integrated into the Matrix protocol? we first assume that we have a set of available relays. So in this example, we have 3 relays that can be used by any matrix room. And also we have a small room consisting of Alice, Bob, and Charlie. And yeah, in the room metadata, we can see the room name, the matrix live chat, and the room members, which are Alice, Bob, and Charlie. And the room is encrypted, and Alice is the room admin. So now Alice wants to add some relays to this room. And she does this by simply adding the room relays 2 and 3 to the room. And then sends the update to Bob and Charlie, so they can update their copy of the room metadata. And this room metadata is part of the event graph containing the room history of the matrix event graph. So what are advantages of relays? So first of all, relays are optional, so peers can choose to use relays, but they can also choose not to use relays. That means the peer-to-peer architecture continues to work even if all relays are down. So relays are not an architectural requirement. Peer-to-peer matrix still continues to work and can function without relays. Also, permissionless innovation is possible because on the one hand side, the peer implementations, they can specify peer relay interactions, for example, how frequent a peer resynchronizes with a relay, or how often a peer wants to synchronize with a different peer. One consideration could be the energy consumption, because if a peer shares his events and his latest events from the event graph, this could obviously consume energy, especially if this is done on a mobile device. And also, peer-to-peer matrix innovation is independent from relays. So our solution works with any peer-to-peer matrix protocols as long as they adhere to the existing peer-to-peer matrix protocol. But whether it's Pinecone, libpeer-to-peer, or Yggdrasil, our relay extension can be used. We evaluated our work and implemented a proof of concept where we extended one existing peer-to-peer matrix implementation with relays. And you can see this code in our GitLab repository. And also, we implemented an automated evaluation framework, which can be used for future peer-to-peer matrix experiments. And with this evaluation framework, we can automate room creation, invitations, the exchange of messages, and build our custom scenarios where we want to evaluate our new peer-to-peer or peer-to-peer matrix implementations with relays. We evaluated our proof of concept with messages from a WhatsApp group traffic dataset. So this is a dataset that contains around about 6,000 WhatsApp chat histories. And we ran 220 experiments in total and conducted some measurements on the performance and reliability of ReP2P Matrix. So here we focus on the performance evaluation. You can refer to our paper for the reliability evaluation. So on the x-axis, we can see the delivery latency, and this is the time between a peer returning online and receiving the first message. On the y-axis, we can see the CDF of messages delivered to at least one peer. And if we look at the curve, we can see that 67% of events were delivered within the first 2 seconds in ReP2P Matrix, while this was only the case for 26% of the events for peer-to-peer matrix. And this is understandable because in peer-to-peer matrix, the peers might have to wait for other peers returning online and synchronizing their state and sharing their state with the peer that has returned online. And therefore, ReP2P Matrix increases the share of up to 2-second delivery times by 50% points. So it's a major performance benefit. So to conclude, we had a look at ReP2P Matrix, which tries to combine the advantages from both peer-to-peer and federated matrix. And our main difference is that relays can store and forward events, so they improve their reliability, and peers can also switch between relays. which means improved performance. And possible future ideas for research could be more efficient multicast mechanisms between relays, or more privacy-preserving mechanisms. So we could try and share less information with the relays. So currently, the encryption keys should not be shared with the relays, but they still can see all the metadata. And this might be an interesting opportunity to do some research on how we can use the relays without sharing too much state with them. Yeah, thank you very much.
Thank you, Ben. That was crystal clear. Actually, even myself, I could understand what you did. So thank you very much. I have a few questions, though. So you talked about everything you can do with ReP2P Matrix, but is there something you can't do? What are the main limitations?
So one limitation is that for each room, the room admin must configure the relays manually. So this is on the one hand a disadvantage, but also an advantage, because each room has the fine-grained control over which relays we want to trust and with which relays we want to share our metadata with.
All right, so do you envision some practical applications for the general public, or is it still very experimental as it is today?
Well, we would, of course, still say it is quite experimental still, and but in contrast to specific applications where you say, okay, I really need peer-to-peer applications of Matrix in catastrophe scenarios, we think that this is more like a first foundational step towards bringing peer-to-peer Matrix into regular use. Like you mentioned the flaws in the beginning, why don't we use peer-to-peer Matrix as it is currently? We would argue one of the reasons is we don't want to miss the flexibility and the comfort of home servers as they are today. And that was our main starting point here, to think about a middle ground. Can we have something like home servers, but with less of the issues of home servers, that still provides you with the benefits, but with less of the drawbacks?
One of the motivations behind that question is if you had some specific plans for the general public or a specific industry. My other question would have been, do you plan to open MSCs for that to make that part of the upstream Matrix protocol? Or for now, is it going to stay an extension of the protocol?
Yeah, I think for now it will continue to be an extension of the protocol, mainly documented in our papers, not really at the stage of actually fleshing out a full MSC for it, more like a proof of concept, like does this in the real sense of the word, does this concept actually is proven to be working? And yeah, we think it did. That would be the next step. But yeah, in that regard, both Ben and myself will continue to work on other projects for now.
Yeah, if I might add something. So I think we concentrated on solving one of the sub-problems of P2P Matrix, and many other problems are yet to be solved. So maybe a step-by-step approach would be beneficial in order to get P2P Matrix going again.
Definitely, and I think you are taking the most responsible approach here. I don't think there is any sense in opening MSCs or trying to upstream everything you are bringing, all your experiment, if you don't intend to build products around that. So if your work is experimental to prove that Matrix can be used for that, but you don't intend to provide commercial support for that, for example, it doesn't make sense to upstream that into Matrix proper. And this is one of the things I really like, actually, to have that flexibility where you can play with the protocol. You can show that we could do more thing. And somebody who wants to sell services and products can do the work of formalizing that in the doc. So very good. You mentioned a GitLab at some point. So the code is publicly accessible?
Yeah, so the code is publicly accessible. So on the one hand, we have the implementation of the relays in ReP2P Matrix, from which you can start either relays or peers. So that's the first level. And on the second, more abstract level, we have the evaluation framework, where you can construct your own evaluation, your experiment plan. And you can measure things. You can measure the delivery times for P2P Matrix and conduct experiments in an automated way.
All right.
Yeah, let me add to that Ben actually prepared a small demo of that repository that to show that it actually works, what we have published there, and that it actually works with the latest peer-to-peer drafts from the Matrix community. That also the paper itself is open access, Creative Commons CC BY, so we managed to be able to put everything out there we had in our research. Ben, do you want to show that?
Yeah, sure. Okay, I'll share my screen. On the left side, we can see a simple YAML configuration file. So what we want to do is we want to configure an experiment where we can send some message in an automated way in a matrix room. So in this example, we have the user, peer 0, and a home server. And in the P2P Matrix world, often the home server moved to the end device. So a home server in the federated matrix world is actually a peer in the P2P Matrix world. And we can configure the password and the port and more users. So we have 2 users in this room, peer 0 and peer 1, and also a relay. So both of these peers use one relay. So this is quite a minimal example. On the right-hand side, we can configure different actions. So we can configure whether a peer should be online and at what time he should be online. So first, the first peer 0 is online, and then the peer 1 returns offline. And while peer 1 is offline, peer 0 exchanges a message with some content. After a while, peer 0 returns offline, and then peer 1 returns online again. And at this point, peer 1 would expect to receive this message from the relay. Okay, and then I'll share a different screen to run the actual experiment. So now I'll start the experiment. So here we can see different Docker containers. We have a container for peer 0, for peer 1, and for the relay. They're just getting started now and getting running. And after a while, room should be created. Yeah, so here we can see the user IDs for peer 0 and peer 1 with the cryptographic hash, and also the relay, and the room has been created. And right at the bottom, we can see how the evaluation or how the experiment is going on. So peer 1 is going offline, peer 0 is sending the event, user peer 0 is going offline, and peer 1 returns online. So now the experiment is finished, and now obviously we want to check has peer 1 actually received the event. So we'll have a look in this log file. I'll just copy the source of it into here. Okay, something didn't work here. Sorry about that.
While Ben is looking at what's what hasn't been working here, let me add that, of course, this is the small demonstration example, what we actually did in the work, and the figure that was in the talk was on doing this on much larger setups of many more peers, using the WhatsApp data samples that Ben found to actually simulate larger and more diverse groups than just 2 peers and one going offline and the other one still receiving the message.
Yeah, right. And now I've got the actual log file, so we can track the whole experiment. We can see the timestamps of at what point in time which event took place. So peer 0 sent this event after approximately 3 seconds. And we can also see that the relay 0, so the relay received a resync request and replied to the resync request. And at last, the peer one actually received exactly this the same message. So this is an asynchronous message. This was a message that was relayed by the relay, and it was received by peer one.
And with that, you can show that the experiment is successful. Congratulations.
Yes, right.
All right. So who do we need to thank for getting you to work on that?
So I think first we have to thank Florian, because this was actually the subject of my master's thesis, and he was one of the supervisors. And it's obviously his research area at the moment. Yeah.
All right. Well, thank you very much.
Also, in that regard, the German state and the Helmholtz Foundation, which were so kind to give us the money as part of the core informatics research project of them, where we look at the science of decentralized messaging, where this was apart from. So the German taxpayer.
Right, very good answer. Well, thank you very much, German taxpayers and all the institutions that allowed you to work on that. You mentioned earlier that you were going to work on plenty of other things. What are they? What are your plans for future research?
So I'm at the moment pursuing a PhD at the same university, the KIT. I'm at the Department of Telematics, and I'm working on traffic engineering at the moment. So I'm looking at the great big networks in the world and looking on how to accelerate and optimize traffic engineering with machine learning methods.
So in a way, we have to be sad that we lost him for now for continue to work on Matrix. But yeah, for me, it's I'm also still doing my PhD at Karlsruhe Institute of Technology in a related department, and yeah, still on the topic of the security and consistency of matrix-like systems. So, like, I provided the theoretical part, and Ben was very good in actually providing practical parts and actually providing Docker containers and runnable code, and not just theoretic models like you're used from my side.
All right, excellent. Is there anything else the world should know?
If you actually want to continue to work on this, dear listener of Matrix Live, we actually provide the courses with everything you need to know to fix these flaws at KIT. Like you can actually learn in the lectures on how does Matrix actually work, how do those peer-to-peer technologies actually work. So if you want to step up and fix these flaws, finally, you can learn everything you need to learn for that here.
All right, excellent. Well, thank you very much, and I see you next week, Matrix Live.
Thank you for having us.
Thank you.